All right, for a really quick lecture, I'm trying to do these quickly so you don't spend too much time. That's why I'm laying out the times of each lecture. I want just to introduce you. I've been doing these big things like Trump tweets and stuff like that. You see the data. You can actually make your own data very easily, and I put it up here. So you look at this right here, right? Salary. Just copy it. I'm going to copy this and put it down here. Now you just you name it and create a vector. So all you do, you can put an equal sign here. I prefer, because the equal sign is used for other places, to use that little arrow and a line plus a C. And then make sure you differentiate each point with a comma, and that's called being comma delimited. And then you make a vector. So now we have created one. So we didn't even need a Excel sheet. So then you look, salary, it's right here. Does it pop up, etc.? Yes. But what's interesting, we're going to run really quick. If you're a lawyer, gender, right? Now this is female or male. And I'm going to explain to you this. I'm going to copy this and put it down here. Notice that these are, if you're doing nominal variables or any kind of categorical variable, these are in quotes, and then you have this outside the quote, that is the comma. So try not, I always make mistakes. That's why I put it up here. Because you put because we, in the United States at least, put the comma within the quotes. Here you cannot. You have to differentiate them, and you need to use quotes anytime you create a vector. And now it's called gender with, watch this, gender with nominal variables or any kind of categorical variable. So let's say you're a lawyer and you come up with this data. Now, because people love money, you're a corporate lawyer and someone's suing because she claims that she's not making money, right? Because she's a female. If you're the business is a corporate lawyer, or if you're the lawyer defending this woman, and I do support that women make the same as men, you can actually use large N data sets to support your cases. So in this case, it would be, oh, I went to the company, I got a sample of the gender as the variable with two attributes, female and male, and the salary. So these match up perfectly. So this female, if it's first, would be this salary, right? Because it's the first. So let's take a look. We're going to call it Sue, and it's just the LM function, because as long as the independent variable, that is here gender, is nominal, that's fine. As long as the independent variable is quantitative, you can still use the LM function, and that's what we're going to use for our big data set when we do the big research on the gorillas. But I figure a lot of people want to study law and understand other things, so we might as well use this as an example. So we created two vectors, and now we're going to put them together. The dependent variable is, remember, this. The dependent variable is quantitative, and then you can use the LM function. Sometimes I mix up independent, but don't worry about it. When you make mistakes, it gets errors. That's common. Our studio does not hate you, but it is like a dog. It smells fear. So we're going to put salary as first. It will not work if you put gender first, and then gender. Now, it doesn't have a name. It's not a data frame or anything like that. So we just do it like that. We do a summary, sue. And there's Sue. You're suing. You're having a party because someone's going to win. Now, what's interesting about this is we see the information, and hey, it is statistically significant, right, at 0.0459. Now, this is an interesting example because it's right below 0.05, so we can say there is a negative decrease, and 2.191 is good for the model. But the thing is, this is the decrease, but it's male. And like you'll learn, female is the base here. It's basically a base, female. Why? Because F is first in the alphabet. So R just uses the base depending on whether it's A, B, C, D, E, F, G, H, I, J, K, L, M. So F comes first. But what's interesting is this would support the business saying, look at, she's not getting a good salary because she's not doing well, but look at, in our data, it's showing statistically significant, but on the male side, and the male, because that's negative, is making less than the female. The multiplier square is not the best, right? But you could still say, hey, based on this p-value, it's below 0.05. And because this is negative male, this is making less than women. So that is one way to do regression analysis, but with a nominal variable. That's nominal because there's no order to male or female as the independent variable, and the dependent variable is quantitative. And that's actually what we're going to do in the gorilla data set. Now, in addition to this, you could just see, oh, how many male and females do we have? Just do a table, right? And you'll do gender. And boom, oh, we have the exact same thing. We have 8 female, 8 male. Very small data set. It's not like our huge, and let me say huge, Trump data set that's got, here I am again, 20,761. I can't even count that high. But this little sample of the business is basically saying men are making less than women and not vice versa. So this is an interesting model, because you can use it in law, and you can use this with a lot of things, right? As we're going to see later with, say, radiation, poisoning, etc. But large N data is very, very important for law. In fact, I'm going to put up a supplemental Harvard a syllabus on law and statistics. Now these universities are having a mandatory class. I don't know if ASU does with law. If you study law, you have to study a statistics class, and that will really help people get jobs if you know this basic regression. And if you're able to do it, I mean, that's great. See you later, everyone. And just if you have any questions, community forum.